number 1, we'll talk about something called the slope of a line. I've given you 3 pictures here with 3 different roofs. And I'm going to ask you this question. Which roof has the steepest house? Actually, it should be the other way around. Scratch that. Which house has the steepest roof? That's a better question. And the question is, I want you to not just tell me which one, but use numbers to justify it. Many of you probably picked C, right? Yeah, that one seems to be the steepest. Because why? I don't know if you can see on the actual diagram, but there's something called a rise and a run. I'd like you actually to count the number of squares. So the run here for the roof A, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Rise, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. So for roof A, if I look at the ratio of the rise to the run, the answer is 13 over 13. So that's just 1. Okay. Roof B answer is definitely not the steepest, but how can we tell with numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then 1, 2, 3, 4, 5, 6, 7. Roof B, 7 over 12, right? So this number is definitely less than 1, so that's flatter than roof A. Finally, with roof B, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So roof C has this ratio of 14 over 8, and that number is actually bigger than 1. And notice then this has the steepest roof. So how can we tell using these numbers? Well, it looks like this ratio, or this fraction we created, talks about the steepness of a roof. And we have a special term for this. Okay? This ratio, which is called rise over run, that's what you see in the notes here, right, is defined as slope. So slope measures the amount of steepness of a given line segment relative to the x-axis. So always relative to the horizontal. Okay? How steep is it measured from the horizontal? And remember from like the chapter 4 extension, we talked about a rate of change. That was the change in the dependent variable. Divided by the change in the independent variable. And sometimes we use this notation. Delta y over delta x. That triangle means delta, which represents change. Well, this change in the y value, this delta y, is often called the rise. And the change in the delta x is often called the run. So now we have this idea of slope being equal to the change in the vertical distance divided by the change in the horizontal distance. And if that is too much of a mouthful for you, that's why we say the change in the vertical distance is the rise, the change in the horizontal distance is the run. Okay? So in the coordinate system, if I put like it on the x and y axes, let's say I have one starting point here. I'm going to call it x sub 1, comma, x sub 1, comma, y sub 1. And let's say on the second point over here, I'll call it x sub 2. That sub means subscript, okay? Y sub 2. And if I actually wanted the slope of this line segment, we would be calculating the rise. Now the rise is this change. This is the rise. And then we would have to calculate the run, the change in the horizontal. So how do I describe the change in the vertical? I'd be taking these two y values and subtracting them. Y sub 2 minus y sub 1. And similarly, if I want to change in the horizontal, x sub 2 minus x sub 1. And this, my friends, is called the slope formula. Slope can be defined as rise over run, or in the coordinate system, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This you should memorize. Okay, you're going to use this concept all the way to calculus and beyond. And to help you with it, I've created another song. Yeah. Don't know if you guys like singing songs, but I want you to think back to a song you learned way, way back when you were probably in preschool or daycare. Remember those days? Yeah, good times, right? All you have to do is play, 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 eat and play, 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 eat and play. Well, there's a song there that is called Row, Row, Row Your Boat. Remember that one? Row, row, row your boat gently down the stream. Merrily, 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 life is but a dream? I don't know. I forgot it. I never learned that version very well because I had another version in my mind. Okay? It's the song lyrics to the slope formula. Okay? So this is to the tune of row, row, row your boat. Okay. And I'd like you to copy this down because you're going to have to sing it too. Here's the slope version. Here's the first line. Slope equals y sub 2 minus y sub 1. And then the bar divide by, right? All over x sub 2. And then minus x sub 1. There you go. Slope equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. See? Catchy tunes. Get it in your head, memorize it, and know it well. That's your assignment, to sing this 10 times. Or more. Alright, here's example number 1 now. Can you find the slope of the following line segments? And I also want you to draw it out on the grid to double check. Okay, so negative 1, comma 2, negative 2, that's down here. B is 5, comma 9, way up here. But if I wanted the idea of the slope formula, remember slope equals y sub 2 minus, okay, so we better actually label these, right? X sub 1, y sub 1, x sub 2, y sub 2. So slope equals y sub 2 minus y sub 1, so 9 minus negative 2. All over x sub 2 minus x sub 1 minus negative 1. So this becomes 11 over 6. Now if you think about it, calculate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6. There you go. Right? 11 over 6. Okay, C, 1, comma 10. Woo! 5, comma 6. Oh, 5, comma 6. Woo! Let's label slope equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Negative 4 over 4. That's the same thing as negative 1. Let's take a look. 1, 2, 3, 4 down. 1, 2, 3, 4 across. Yeah, which is the same thing as me going 1 down, 1 across, 1 down, 1 across, 1 down, 1 across, 1 down, 1 across. Same thing. Okay. Let's do part C. I'll use blue. Negative 7, negative 6. Way down here. 3, negative 6. Oh, this is an interesting line. There is no rise. Okay, let's do this. Slope equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Look at this. 0 over 10. That's 0. A slope of 0 represents a nice flat horizontal line. Okay, last one. 8, comma 5. Doot. 8 comma negative 8. Ooh. Doot. Look at this. Vertical line. Slope equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Look at this. We're dividing by 0 now, and we can't do that in math. How do you divide by 0? So we call this undefined. So an undefined slope actually produces a vertical line. Whoa, trippy, trippy. Okay. Wow. Well, can you do number 2 now? Don't need to draw them out ever again, right? We can just find the slope of these line segments using the song. Slope equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Notice here that the y values are the same. So therefore, when the y values are the same, what do we see? The slope is equal to 0, and we get a nice horizontal line. Okay? Interestingly enough, the next part, the x values are the same. So what goes on here? Slope equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Look at this. The slope is now undefined, just like before, where we know this is a vertical line. So we can see that if the x value is the same for both of the coordinates, we know we have a vertical line, undefined slope. Yet if the y value is the same for the two coordinates, we have a 0 slope or a horizontal line. So let's just summarize all the different types of slopes. From above, we found that if I have a horizontal line from left to right, this slope is what? Yeah, 0. If, however, I have a vertical line, what we know is that the slope is undefined. And then what are my other two situations? Well, the other situation is when it's going upwards like this from left to right. Notice that a question like that is like part A, where the slope was a positive number. Positive. And finally, if I had something going downwards from left to right, what do you see? Yeah, you got a negative slope. And that's evident from part B in example number 1. So these are the 4 different types of slopes you can see. Alright, and now we're going to turn to page 3, and let's see if we can apply it to a few questions here. Okay? Given that you got point A and point B, this time I told you the slope. Can you find the missing coordinates? So not too much more difficult. X sub 1, y sub 1, x sub 2, y sub 2. I'll use the same idea, right? Slope equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Now, in this case, though, the slope is equal to 3. So I'm going to make this 3 equals to negative 12 over x minus 4. And now you just need to solve. This is the same thing as 3 over 1. We can cross multiply if you wish. And then if we solve, 3 bracket x minus 4, close the bracket, equals to 1 times negative 12. We'll distribute the bracket. Look at this. 0 equals to 3x, so x must be equal to, that's right, 0. Okay? You try number 4 yourself. Okay? Read it, try it, double check your answer with me. Negative 1/4 is equal to negative 5 plus k, negative 1/2 k minus 1. Cross multiplying again, I get negative 1 times negative 1/2 k minus 1 equals to 4 times negative 5 plus k. We'll simplify this to 1/2 k plus 1, negative 20 plus 4k. 4k minus half k, that's 3.5 k, or 7/2k. And then 20 plus 1 is 21. And I can try to solve this by multiplying now 21 by 2/7. And I think that just equals to, that's right, 6. So k equals to 6. If you got k equals 6, yay! If you didn't, see what you did wrong, whether it be a calculation error or a slope error, figure it out and learn from it. Okay, here we go. Number 5. So, I don't know if you've seen these signs before when you're driving around. Maybe you're not driving, but your parents are. But a slope of a road is often called the grade of the road, which is really the slope expressed as a percentage. So when a grade is greater than 6%, they have a sign that they put up because that means it's pretty steep, okay? To warn that you're going down a pretty steep hill. Now in this case, the sign says 20%. So I want you to write the slope as a fraction in simplified form. Well, if the grade here is 20%, what is that as a fraction? Yeah, it's actually 1/5, right? Or 20 over 100. Simplified to 1/5. But remember, this is a downward slope. So remember, downwards, which means that my rise is actually not positive. What do I have to change this to? That's right, because if I draw a picture, it's actually going down 1. Run 5, make sure that's negative. And now the answer is right. Okay, so that 20% is actually negative 20. Okay, now, if the slanted road in the picture actually measures 2 kilometers, wow, that road itself is 2 kilometers, can you determine the change in the vertical distance from the top of the road to the bottom of the road? So what I'm saying is, look, here's that real road, the real road. That slanted road there is 2 kilometers. I want you to find what? The change in the vertical distance from the top of the road to the bottom of the road. So I want you to find this value, the vertical change. So remember, the slope is another right angle triangle, and we found this as 1 and 5, right? That's from above. I guess we need that slanted side. That's right, Pythagoras to the rescue. Let me call this slanted side S. So 25 plus 1 is 26. That equals to S squared. So S equals to the square root of 26. Okay, this is root 26. So now how do we solve it? Well, this is where we can use similar triangles, remember? The corresponding sides, the ratios are the same. So if I were to do this as y over 1, that's the corresponding heights. That is equivalent to the corresponding slanted parts, 2 over root 26. And then I guess I can solve for y, cross multiply if you wanted to, but you don't really need to because y over 1 is y. So y is just 2 over root 26. And if you need a calculator to do this, please do it. 2 divided by root 26 gives you approximately 0.39. Is that kilometers? Yeah, kilometers. Okay, or I guess if I want another decimal, that's 392 meters. There you go. That is it for now. Welcome to Slopes of a Line.